Now from 8th standard, see, your learning process, you should be learning centric and it is not teaching centric. So you have to involve yourself in the classroom discussions, you should analyze, and that effort will get converted into knowledge. Okay, so that is basically what I have explained here. And most importantly, physics can best be learned by experimentation. So experience, experiment, experience and learn. So I have tried to do that in this small classroom with a laboratory setup, etc. And you are able to see the experiments on the board. I got an electronic board here and we were able to analyze all of them. Alright, and further you see, whatever has happened in the class, you have to go back to home and you should study from the textbook. So you should corroborate what is given in the textbook to what experiments that we have conducted, make notes out of it, okay, and then attend all the tests very sincerely. Then you will have better understanding of the subject. And remember, whatever we have learnt now is one level of knowledge. You need enhanced knowledge. Knowledge can always be enhanced. That happens during the coaching sessions. And then of course, how to use this knowledge, application of this knowledge, solving numericals, that becomes the training part. Okay, so it is very essential that you thoroughly understand the entire syllabus, and with that in view, well, we have conducted the experiments and we have analyzed it in the class. Alright, now as you know, well, this is hybrid class, and we have got a wonderful interactive panel through which we have been able to get the experiments on the board and I could analyze it here. Okay, so it's a wonderful combination of technology, engineering and teaching, etc., which has made learning really enjoyable and very, very effective. So this chapter, magnetic effects of electric current, as you know, it is for the 10th standard. Of course, any other grade students can also learn from this. And what I have done here, I think, we have tried to realize the experiments in its real time. Okay, and then of course we have conducted around 20 experiments here and around 15 classes, 15 1-hour sessions. We have discussed it elaborately, and now I am going to summarize all of them in 1 hour. So it's be like you write summary sheet. Now with the technology, you are going to have summary sheet with live experience. Okay, well, so that's it. So now we are going to enjoy the experiments here. Okay, well, so these are all the topics that we have covered. So as you remember, we first understood the magnetic field of a bar magnet, and then we also were able to feel the Earth's magnetic field, and then we were able to feel the magnetic effect of electric current, current being passed through a coil. Then electric field, electric effect of magnetic field is relative motion, that is Faraday's experiments. And then we understood the concept of magnetic field lines due to current, tracing magnetic field lines of different types of magnets. Then we had an experiment with Lenz's law. It was a fantastic experiment. And then we have the Ampere's swimming rule, introduction to motor, current in a circular coil, Fleming's left hand rule, Fleming's right hand rule, its application to DC motor and AC motor, and also the generators, AC and DC generators. This is all there for your syllabus. So you know this is the magnet, and we have played with this. Okay, so you know the first thing is what will a magnet do? What will a magnet do? Attract the what? Anything? Magnetic materials. See, now this is a magnetic material, it is getting attracted. So you saw that. And now what you have to observe is, I will keep this material here, and I am bringing a magnet near this. Okay, right? Now you see, as I bring it, nothing is happening to this. As I bring it closer, then you can see some movement, then it got attracted. Okay, so what did you understand from this experiment? To disturb this. Okay, then I have disturbed it. So the magnet should return back to any position. So supposing if you hang me and suspend me in a thread and then you rotate and leave, I will then come back to any position. No? Can you imagine? I can come back to any position I want, or you hang something here in this room, right? And then you rotate it and leave it. It will come back to any position that, at that particular moment. But here you will see that this black color magnet is always returning back to this position only. That is, the north pole of this is always at this point, right? Only if I bring another magnet near this, only then that is getting disturbed. Otherwise it is there only. So why this magnet is always pointing towards the geographic north? Magnet. Okay, see now you can see all these magnets. See, you can see the small magnets here. Are they getting affected?
Yes, sir.
They are all getting affected. So what does it mean? That this magnet has influence everywhere. So every magnetic compass is getting affected. And now did you observe? These magnets have changed the position.
Yes.
Hello?
Yes, sir.
Why did it change?
Because that wire became a magnetic object because current was flowing.
Who told you current is flowing in that? How did you find out?
Means the ammeter is.
Excellent. The ammeter is showing the reading. So you can see here that I have got a coil of wire here. Okay, so this is the coil of wire. Okay, so I have taken copper wire and I have made it into a coil like this, which has got 50 turns. This needle has turned like this. So that means there must be one more magnetic field which is influencing it. Right? So now, the position of this magnet here, of this small magnet here, is the resultant of two magnetic fields. One magnetic field due to Earth, another magnetic field due to this coil. So Earth's magnetic field like this, and the effect of this coil like this. So the resultant is this. So these magnets are all now in a position of the resultant magnetic field. What did I say?
Resultant magnetic field.
So I hope you know resultant. So when two vectors are acting simultaneously, then the combined effect of them we call it as the resultant effect. So you can see here, this magnet is also showing north pole here, south pole here. Current is still flowing in the conductor. Got it? Hello?
Yes, sir.
Now you see, I am going to move it closer to the conductor. Now did you see the change? What is that? What did you understand from this experiment? That is moving this compass needle far away and closer. I am moving it closer because Aryan wants this to be moved. Okay, did you see it moving?
Yes, sir.
Okay, still you are not convinced? I will convince you.
Not convinced.
Now convinced? See, I turned off the current.
Alright.
I turned on the current, it moved. Observed?
Yes, sir.
Good. So this experiment clearly proves all this. So from electricity we can get magnetism. Right? So that is the chapter for. Leave the magnet. See, now it is stationary. Now I leave my hand. Okay. So as I push the magnet inside, you saw the deflection. And again it stopped. You can see here.
Yes.
I pushed it inside. It deflected and came back. Did you saw?
Yes, sir.
So explain this. So what is there around this?
Magnetic field.
That magnetic field is linking the coil.
Influencing.
See, you have to learn to imagine, gentlemen. And see, you must not go by words. See, now as soon as I show you this, see, I started the journey. Around this, what do you see?
Magnetic field.
How do you see? You have to imagine. You have to imagine. Understand? Around this there is magnetic field. Okay? So what is there around this? Magnetic field. And this magnetic field is linking the coil. Can you feel?
I'm not able to imagine.
You are not able to imagine. Okay. I will make you to imagine. Was a thread to the thread I have connected some magnetic discs. Okay. Now these magnetic discs have got north pole, south pole, north pole, south. Understood? Each of these discs has north pole, south. Now what you have to understand is that there is something called as magnetic lines force, which I will be explaining to you. But if you have seen the book, you would have seen this there.
Yes.
So what are these red color things that I am drawing?
Magnetic field.
Magnetic field lines. They are imaginary. You don't see any field. Okay? They are imaginary lines. So the moment you see a magnet, around the magnet you must be able to appreciate this revolver. Understand? Magnet is a material, but around it what is there? There is magnetic field. Okay, so and now what I did here was that there was a coil. Can you see this coil? So this is the same coil, right? This is the same coil that you see, right? So and I kept the magnet here, and then what I did, I kept this magnet, and this magnet was made to move up and down. Actually first one. So when you make the magnet move down, what happens? The magnetic field will be linking this coil. Here, supposing I take a cylinder, okay? So I made a better arrangement today. So I'm going to. So this is now completely out. Okay?
Yes, sir.
So I'm going to leave my hand. So if I leave my hand, what will happen?
The magnetic field will link with the copper.
Good. The magnetic field will link with the copper coil, and then what happens?
Induce electricity.
It will induce electricity, electric current, and the galvanometer will show the reading. So that?
Yes, sir.
Huh? So now if I pull it out, now you saw, okay, see now here, okay, now I am going to, I have pulled this magnet outside, so there is no magnetic field linking the coil. So the moment I release my hand, then the magnetic field linked the coil, and you saw that it deflected to the left and came back. Did you see that?
Yes, sir.
Now I am going to pull this magnet out of the coil. Now what should happen? But the deflection will be to the right. That means the current induced will be in the opposite direction, because there is, see now, change in magnetic field. There is lot of magnetic field inside the coil, but it is stationary. It is not in motion. The magnetic field must be in relative motion with respect to the coil. So it is at rest. So there is no current. Now I will forcefully retract it. Now you see, 1, 2, 3, chuck. You saw it deflected to the right?
Yes, sir.
Beautiful phenomena. Understood?
Yes,
Huh.
sir.
Now you see the next experiment I will do. Now here I was moving the magnetic field and the coil was stationary. Now I will make the coil move and the magnetic field stationary. Now what should happen?
Same
Still,
in the galvanometer.
It should happen the same thing.
Yes,
Yes,
sir.
sir.
Okay. 1, 2, 3. Did something happen?
Yes, sir.
You can see now the magnet is stationary but the coil is moving, and you can see the galvanometer is deflecting. Got it?
Yes,
What does these two experiments prove? When will the current be induced?
Set the coil on the hand.
If it is in motion, no.
If it changes,
The
so if the linking changes.
linking changes. Okay. See now, you see that's what is physics. See now, I am going to do the third experiment. You said you are using the word motion. See now, here. Both of them are moving. Is there any deflection?
Yes,
sir.
Both of them are moving. Can you see deflection?
No, sir.
Huh?
No, sir.
See, if both of them are moving, no deflection. If one of them moves with respect to other, there is deflection. So, the right word you should use relative motion. The right word you should use is relative motion. The magnetic field must. You can see here, and you can see here. See again here, you see that the magnetic needle is like this. Here the magnetic needle is like this. Can you see? And I have drawn a circle. So what you have to understand is, see, this magnetic needle is representing what? This vector is representing what? The magnetic force on this magnetic needle. This white color is a vector which is showing what? Magnetic force on this magnetic needle. And here what you notice? Same. There is a magnetic needle here, it is experiencing force. That is shown by this vector. And both these force vectors are tangential to a circle that I have drawn with this as the center. That is what should have been your observation. This is called as observation. Okay. Now what happened? They are all? Hello, what happened? Deflected. Now what did you observe here in the deflection? You can see all of them have deflected.
Yes, sir.
So is there something which I can relate?
So it's forming a circle.
What is forming a circle?
The magnetic needles are in the shape of a circle.
Magnetic needles are not in the shape of a circle, I am sure. Magnetic needles are not in the shape of a circle.
Tangential directions are continuing in
Come on, everybody come on, tell. Come on, tell. Yes, they have got oriented. Is there any relation between this orientation?
Like the top one and the bottom one compasses are there.
Huh?
They are still like similar. Like the deflection is a bit similar. Like the opposite compasses are having the deflection same.
Huh. Okay, some observation. See, just now I taught you, you are not able to learn. You have to learn. See now, what is the relation between all the four? Supposing you draw a circle. Hello?
yes, sir.
Then what happens?
Draw the wrong thing.
The needles will all be tangential to the circle. The needles will all be tangential to the circle. Don't you observe that?
Yes, sir.
Right? So what does this experiment prove? What does it prove?
Magnetic field. If a circle is drawn through all the compasses, then it is the needles are in tangential direction to the circle.
Yes. So now what you have to appreciate here is that this circle that I have drawn, here, can you see this circle here? Hello?
Yes.
Okay? Okay. Now I can draw a similar circle here. Here also. Okay. Of course, this is the video, it is not taking the drawing, but I am showing you the excerpts here. So here you can see this yellow color circle that I have drawn, that is actually the magnetic lines of force. The yellow line that I have drawn is magnetic lines of force. Now, can you see any magnetic line of force here? But now if you imagine that there is magnetic line of force passing through this, if you imagine, then yes, it is there. Okay, so the taatparya of this experiment is, now you see, what is the direction of the current in this? The direction of the current is in this coil. In this coil it is coming in towards you. The current is coming towards you. You understand? See, I have got a coil there. Okay, so the current is coming towards the upper direction. Can you see there?
Yes.
And in this part of the coil, the current is entering inside. So here it is coming out. Hello?
Yes.
Right? Now here the current is coming out. That means the current is coming out. Now the magnetic field is encircling it. The magnetic field is encircling it. Means it is in the form of circular shape. That is precisely what this experiment is proving. Understood? So this is one circle that I have drawn. So if I now keep the magnetic needle somewhere here, anywhere, so you have to go on drawing the circles. So the magnetic field around this current carrying conductor will be circular in shape. Correct?
Yes, sir.
So on this part of the coil, the current is like this. Okay, the magnetic field is circling in anti-clockwise direction. On this part of the coil, if I keep the needles here, what will be the direction of the magnetic field line?
Clockwise.
It will be clockwise. Okay? See, this is nature. In nature, you find these things. We are only. See, if there is a current carrying conductor here, what does these lines represent? Magnetic field lines. Hello, is that clear?
Yes, sir.
Okay? Now, you can see that there are arrows here. Can you see?
Yes, sir. Yes.
Now, supposing the direction of the current instead of going up is going down. Supposing the direction of the current is now down. Then what happens to these field lines? They will be same, isn't it? What happens? The magnetic field lines will now be in the anti-clockwise direction. What does this diagram depict? Tell. Loudly you tell.
Magnetic needles arranged in a circular.
So I have arranged different magnetic needles here. Like this. Okay, anybody else? See, all of you are intelligent. That's what you feel. And your parents also say you're intelligent. Good. It's a good feeling.
All of the needles are tangential to the magnetic field.
All of the needles are tangential to the magnetic field. I want better explanation. As students of science who have understood, they will explain better. Those who have not understood will give some answers, okay, and say, oh, I have understood. Come on, tell me, what does from this diagram, what do you understand? As students of physics, explain these diagrams. Right? You can see I am sprinkling it. You can see the orientation of those lines.
Yes, sir.
See, don't you feel excited? See, this is the nature, and this is the beginning of a long story that you are going to enjoy throughout your life. This is the beginning of electromagnetism. So you can see that there is orientation, right? So you can see can you see its orientation, all of you?
Yes, sir.
Hello, is it clear?
Yes, sir.
Yes, sir.
So what is the direction of the magnetic needle? See, that notch on the bar magnet is the north pole, right? What is the direction of the needle?
South is pointing to the north of the bar.
Excellent. South is pointing to the north. Okay, great, wonderful. Understood? Hello.
Yes, sir.
Yes, sir.
So you can see here that this is the magnet. You can see the north pole of the magnet, and the south pole is pointing like this. Don't you see this happening here? Hello.
Yes, sir.
Hello.
Yes, sir.
Now I will keep it here. Can you see the orientation?
Yes, yes.
Like this. You can see the orientation?
Yes, sir.
So you can see here, you observe, what you have to observe is, from here there is a magnetic field line which is coming up, here, perpendicular. That is why this is also perpendicular, tangential. From here the magnetic field line is coming out like this. You can see here, hello?
Yes, sir.
Yes, sir.
See, from here the magnetic field line is coming out like this. Can you see this? Okay, so if you extend it, it will be tangential. If you extend it here, it will be tangential. If I keep it here, again you see the orientation there. So again the orientation, so I am keeping it here, so the orientation will be tangential to this. Here. Can you see? It is parallel to the bar. So this is it. See, again you see the north pole, south pole. It is tangential to this point. Okay, so I bring it here. Again you will see the similar phenomena. That is, but now you see that they do not cross. That is very important. Okay?
What if you break at the center, like
Louder.
what if you break the magnet like north and south exactly, and in the middle if you break only north on this, but it will become more again north.
Who will answer this question of his? He is telling you cut this magnet here. You cut this magnet here. So what will happen? Yes, Rajdeep.
The other end becomes the south pole or the north.
See, you have to understand it like that. So if you cut the magnet here, then this becomes south pole, this becomes north pole.
Automatically requires that.
Automatically it acquires. Any question?
It's how are not.
See, just now I told you a statement. You take any tiny magnet, it will always have north pole, south pole. That theory what I have given is sufficient for you to answer your own question. If I had cut a magnet, it will automatically become another magnet with north pole, south pole. You make this into any number of tukdis. North pole, south pole. North pole, south pole. Any number of tukdis. So, in other words, this bar magnet is a magnet of magnets. The bar magnet is nothing but consisting of many tiny magnets. Each tiny magnet has got magnetism. Clear?
Yes, sir.
Good. Anybody has any other doubts? You should have n number of doubts here.
Sir,
Huh.
why a magnet always points to north?
Why a magnet always points to north? Okay. So for that, you see, now you know Earth. Earth itself, you can assume that there is a large bar magnet in the Earth. Assume to begin with. There is not, but for us to assume and learn, it is easy. Assume that you have got Earth. Yes, there is Earth. There is nothing to assume. Okay. And now this is the geographic north of Earth. Our north pole is there now.
Yes, sir.
And this becomes the geographic south. Right? Now here you can assume that there is a magnet inside Earth. There is a magnet inside Earth. Okay?
Yes.
And this of the Earth will be south pole and this will be north pole. So what is this? This is magnetic south and this becomes magnetic north. So that is why if you keep a magnet here, if you keep some magnet here, so this magnet, see now the magnetic lines of force will be like this. Like what? Like this. Understood?
Yes, sir.
See the magnetic lines of force are like this. Hello?
Yes, sir.
Sorry. See magnetic south will be like this. Magnetic lines of force will be like this. So if you keep a bar magnet here, so this bar magnet will orient such that this magnet, there is a hollow copper tube, okay, and it is held vertical. And Mr. Rajdeep, show me what you have in his hand. Yeah, I think you can see this black color thing. That is a magnet. Alright. Now Mr. Rajdeep is going to drop the magnet not through the rod but from this height. And you have to observe the time it takes to fall. Okay? The time it takes to fall. Alright, once again. Connect it.
Inside.
No, outside. 1, 2, 3.
Yes.
Yeah, it hardly took 1 second to reach the earth. I hope all of you observed. Where is the magnet? Yeah. Right. Now, this magnet is going to be dropped into the copper tube. Okay? And when I say to drop, you drop it, and when it falls down, you keep watching down. The moment it falls, you should clap. Alright. 1, 2, 3.
Yes.
It's falling, fall! It took almost 3 seconds for the magnetic piece to fall through this rod. It is approximate time taken for this was hardly 1 second. Hardly 1 second. So it had a free fall. Okay. Now, when this object was inserted into this, and then it was let to freely fall. Again it came down here. This object came down here. Okay. And this time it took almost 3 seconds to fall. treat it as coil of wire. Got it? So now this magnet is moving through many such coils, just like how the magnet is moving through many such coils. So this in turn, you can see here, this in turn will give rise to, this in turn will give rise to current. Hello?
Yes, sir.
Just like this current. And this current will give rise to magnetic field. So in nature, there is one thing. Everything is stable. Eddy currents. Eddy currents. Not eddy currents, eddy currents. Understand? So it is because of eddy. So friends, we are going to conduct one more set of experiments. Now what I want you to understand is, well, I have this coil, right? Now this coil, similar coil, I have kept it here. If you can observe, similar such coil, I have kept it here. Where is?
Below the compass.
Yes, below the compass I have kept a coil. Okay? Right. So you can see that I have got a coil here, and obviously the one that is hanging here, you can see. So this has to be a magnet. Okay? So this has to be a magnet. So I'm just suspending a magnet on top of that coil. The coil is horizontal, and then you will also see that I have kept a magnetic compass here on this. I hope all of you can see this. This is the magnetic compass, this is a coil, and this is a magnet that is suspended, and then you have got a ammeter. Alright? So now I am going to switch on, and the current will start flowing in this coil. I am going to switch on and the current will start flowing in the coil. Okay? Now think and tell me what will happen. If I switch on, the current will start flowing in this coil, either like this, okay, or in this direction, right? So if the current flows, what will happen?
Magnetic
The
field
magnetic
is created.
field.
Okay, so the current will flow in the coil, magnetic field will be created. Good. Right, continue.
Compass will deflect according to the relative magnet.
Compass will deflect. And what about this magnet which is suspended?
It will also create magnetism.
It will also experience force. Good. Now, very good. This is the first level observation. Now you can see that there is compass needle. So in what direction will it deflect? Clockwise or anti-clockwise?
So it depends on the flow of current.
It depends on the flow of means
Direction of flow.
direction of flow of current. It depends upon the direction of flow of current. Okay. Now you can see that I have kept the compass needle above the coil. Alright. So I am going to turn on. So I just now turned on. What is the current that is flowing there? So this coil that you see, that is what I have kept here flat. You must clasp it with your right hand. Like this. Can you see? I have clasped it with my left hand, right hand. So the thumb is pointing in the direction of current. And my fingers are motor here. Okay, can you all see? Hello? So how I am demonstrating this is because, okay, so why I am demonstrating this is because now this is an electromagnetic phenomenon. I am passing current into the motor, I am giving electrical energy to the motor, and in the motor this electric current will give rise to magnetic field. And inside this motor there is already one more permanent magnet. Bar magnet is a permanent magnet. Like that there is a small magnet. Alright. And these two magnetic fields, which two? There is a permanent magnet inside the motor and there is a magnetic field created by the current. These two will interact. Just like how two bar magnets interact, these two will interact. And because of which it will create a torque. Right? And that makes the spindle to rotate. Okay. Friends, now you can see that there is one instrument that you can see here. Okay? I hope all of you can see this instrument.
Yes, sir.
Right. Now let me explain this instrument. Now you know this is the compass. I think already we have used this compass. It has got a magnet, black color one magnet. There is a red dot which is the north pole, and then there is a very gentle stylus that is attached to it. Okay, and then so the magnetic field is entering here due to this part of the conductor. Due to this part of the conductor also it is entering. Due to this part of the conductor is entering. You can see here, if the current is flowing in clockwise direction, the magnetic field is entering into the frame of this coil. Going in the coil, right? You saw that the magnetic needle rotated in this direction, that is clockwise direction. Okay, and the stylus is now making an angle. From this is 0, from this to this it is 80 degrees. It is making an angle of 80 degrees. What does it mean? That means the field is perpendicular to the plane. Okay. Now you can see that I have suspended a coil of wire. Can you see?
Yes.
You can see that I have suspended the. Oh, Mr. Murthy, be careful. Wait. You can see that I have suspended the coil of wire. Can you see here?
Yes, sir.
Yeah. So there is a coil of wire which is suspended, and which is at a certain distance from this magnet. I hope all of you can see that. Okay? Right. Alright. And then to this coil you can see there is a wire connected and all. So there is wire connected to this. We take this mouse this side, and I am able to pass current through the coil. I am able to pass current through the coil.
Yes.
I hope you can see that. I can pass current through the coil. Okay? Now no current is passed in the wire. So what is there? You just have a coil of wire, and then you have got a magnetic field. There is magnetic field and there is coil of wire. Now I am passing current through the wire. Did you notice some change?
Yes.
What is the change you noticed?
The coil of wire.
It's this. You understood Fleming's left hand rule,
Yes, sir.
right?
Yes, sir.
And this is also called motor rule. This is also called motor rule. Why? Because see, in a motor, what you will do? You will create a magnetic field. You would have created a magnetic field. You would have created a magnetic field in a motor. Okay? And then you would have created a magnetic field in a motor. Already you will have permanent magnet or coil magnets. And then what you will do? You will pass current through a coil. And that coil will move. And the yes, see, you tell proper English. No, you are going from English school. AB experiences force in the downward direction. AB experiences force in the downward direction. Understood? Simple. So this is the coil. So this coil, this part of the coil will experience force in the downward direction, and this portion of the coil is pivoted. The coil is pivoted. Pivoted means what? It is held like this, so that this coil can rotate. Can you understand?
Yes, sir.
The coil, the magnetic field is still there, right? And now we are going to give motion to the coil, and the coil is going to produce electricity. Okay? Now you can see here that I have got a coil. You can see, and the ends of the coil are connected by wire to the galvanometer. I think all of you can see this galvanometer. And then you can see I have kept a magnet here, a very powerful magnet here, very close to this coil. Alright? Now so no current is flowing. Right? Now I am going to, well, you saw what I did. Now can you see the deflection in the galvanometer?
Yes, sir.
As the coil is moving, the galvanometer is deflected. Right. Now what you have to observe is when the coil is moving from one point towards the magnet, and another motion is from the magnet away. Okay, you can see now from one point of the coil, say this point of the coil to this point. 1. From this point, so you see here, this is the principle used in generator. In the electrical generator, you give mechanical energy, you rotate the coil, and there is current produced in the coil because of electromagnetism. Clear? Okay. I hope it is clear. Alright. You connect the blades. You connect the blades to this coil. What will happen? The coil will rotate, the blades of the fan will rotate. That's how the fan is made. Right? Hello? To that you can connect many things. You can make a pump, you can make a so many things out of it. So this is the principle of working of the motor. To brief you. Now comes this part. Very important is this part. You understood the motor now?
Yes, sir.
Now you can see that there is a half ring here. Can you see two half rings? See here, you can see the diagram clearly. The same thing I am showing here. Hello?
Yes, sir.
So this is the brush. As I told you, the brush is simply holding. This can rotate.
Yes, sir.
And there are two rings here. Can you see? One ring, there is a gap, and there is another.
Yes, sir.
Okay. These two together will form one ring. मैंने क्या किया? A ring को split किया. इसलिए इसको बोलता हूँ split rings. क्या बोलते हैं इसको?
Split rings.
एक ही अखंड था उसको split किया. Split rings. So these two are the split rings, and these two are the brushes, carbon brushes usually, and they are holding it tight. And then this can rotate. This will rotate. So this will rotate means what? This will rotate, but the brushes will not rotate.
The split rings will rotate, sir.
Split ring will rotate. So the split ring will rotate, brushes will not rotate. Okay? Now you can understand that better here. I will show you. ಆರಾಮ್ ಸೆ ಫಸ್ಟ್ ನಾ ಏನು ನೋಡಂತೇನೆ ಅದನ್ನು ನೋಡ್ಬೇಕು. ಇದೇನಿದೆ ಫ್ಲೆಮಿಂಗ್ಸ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ರೂಲ್. ಸೊ ಇನ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ರೂಲ್ ವಾಟ್ ಆರ್ ಆಲ್ ದ ಥಿಂಗ್ಸ್ ದಟ್ ಯು ಆರ್ ಗಿವಿಂಗ್? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಆಲ್ರೆಡಿ ದೇರ್ and you move the conductor. It will result in current. This is the outcome. But now you see this arrangement. Now aram se see this arrangement. What you see arrangement here? There is north pole, this is south pole. So if there is north pole and south pole, what will be there? In between you will have, in between what you will have magnetic field. Clear? Hello? You will have magnetic field. Okay?
Yes, sir.
So now here you can see that there is a handle. Can you see this handle and all?
Yes.
So if this handle is rotated, what will happen? What will rotate?
The coil.
Louder.
The coil will
Coil will rotate. So in this case, this coil will go down. This side of the coil will go down. Correct?
Yes, sir.
This side of the coil will go down, and this side of the coil will go up.
Yes, sir.
Right? And the magnetic field is like this. You can see. Correct? That means now the direction of motion and the direction of magnetic field are perpendicular to each other. Appreciate? See, ನೀವು ನಾಳೆ ಆನ್ಸರ್ ಬರೀಬೇಕಾದ್ರು ಹಿಂಗ ಬರೀಬೇಕು. In sequential order, you should experience it and write that experience. Correct? No by hearting and writing something. So you should first draw the schematic diagram and start explaining that. So now you see this end of the coil is moving down and the magnetic field is like this. Now apply the right hand rule. So the magnetic field is like this and the motion is down. So this is the direction of the current, the middle finger. So you will see that the current is going in this direction. The current is traveling in this direction. Got it? On this arm, the motion is up and the magnetic field is like this. The motion is up, the magnetic field is like this. The current will be towards the board. The current will go towards the board. So this current will travel like this. Got it?
Yes, sir.
Understood? Now, you see, this end of, see, this diagram is very clear. So this end of the coil is connected to this split ring. Got it?
Yes, sir.
This end of the coil is connected to this split ring. Permanently connected. Split ring is a permanent connection. Split ring tirugura coil tirugutide.
Yes.
And then you have the brushes.
Yes, sir.
So what happens? See here, the current is traveling like this, through the brush, like this, to the bulb, and then it is coming back here. So what happens? The bulb will glow. When will it glow? When you rotate this. When you rotate this. Got it? You rotate it slowly. What will happen?
The current induced is less.
So what will you visually see?
The bulb will go dim.
The bulb will glow dim. You rotate it fast, the bulb will glow bright. More current is induced. Correct? Understood? That means the strength of the current will increase if the rate at which the coil is cutting the magnetic field is more. Got it?
Yes,
So now here you see, the coil is rotating. Sometimes this end is this side, the next cycle this end will come this side, this end will come here. Whatever be the thing, the current in this bulb is always flowing in this direction. Do you appreciate that?
Yes, sir.
Hello?
Yes, sir.
So the current through the load, so bulb becomes the load. You can even connect a fan, some electrical appliance which will take electrical energy. The current is always from this direction to this direction. Got it?
Yes, sir.
So that is why this arrangement gives you what? What is this arrangement? This arrangement is DC generator. DC generator. Direct current generator. In the textbook is wrong, still you have made the same mistake. Okay? And so be careful. See, here, please understand that this connection, what they have done here, this line that they have brought here, it should not be connected to the brush. It should be connected to this slip ring. Understood? Split ring. Even here, this wire should be connected here, not to that. Okay? See, and you can see here, I have elaborated that. This whole thing I have elaborated here. See how the connection is. See, this one is connected to the coil. Understood?
Yes, sir.
This one is connected to the coil. So, the coil is always connected to this. On the paper only you learn. So you draw one conductor like this. So, well, the conductor will give name A to B. The conductor will give name A to B. Then to this conductor, well, you will say the magnetic field is like this. B bar is the magnetic field. Now you have to understand that is the 3D diagram that I am drawing. And this angle is 90 degrees. That is, the magnetic field is like this, the conductor is like this. Okay, it is 90 degrees. Keep this in mind. Some drawing you should do. So this is 90, this is 90. Now the next aspect is what? You are going to pass the current. You are going to pass the current. You are going to pass the current in this conductor like this. Okay. Then what happens to this coil? So you draw on the paper and you should check. See, this effort you have to put. This effort, and only students who have love to learn, will put these efforts. Others cannot put this effort. They think that I will by heart tomorrow examination, previous day I will read book, I will get 90 marks, and in your school also will give you 90 marks. Don't worry, 100 also they will give you. So you will be happy. But you will all understand that the questions when it is asked whether you have understood the subject, you will get 0. Because understanding is not there. So you have to do effort like this. So now here you see. Now this is your finger, current. Right? And this is the finger which gives you magnetic field. Now here what you have done, the magnetic field is into the pole. Magnetic field is into the pole, or you can even say this is x direction and this is y direction. X axis, y axis. Right? Then the motion of the conductor should be in z direction. Isn't it? X, Y, Z. Z direction. So the motion of the conductor will be up. Magnetic field is into the pole. The current direction is like this. Understood? Like this. Understood? The magnetic field is into the pole. The current is in this direction. Right?
Yes, sir.
Now the force is, but the current is ulta. Current is ulta. So the conductor will experience force in this direction, out of the pole. So this will become, the direction of the force here will be in minus the z direction. Got it?
Yes, sir.
X, Y, Z minus Z. Understood?
Yes, sir.
So this format you understood. Now here in the next rotation, see this is P and this is Q. These connection points I am telling you.
Yes, sir.
These connection points I am telling you.
Yes, sir.
Yes, sir.
Okay, and you can call this commutator also as P. This connection is also P. Commutator point is P. Now what happens in the next cycle? The coil would have rotated by 180 degrees. Coil would have rotated by 180 degrees. So this A will come here, and this D will go here. This B will come here. This C will go here. Got it?
Yes, sir.
And so this point P will come here, Q will go here.
Yes, sir.
So this would have also rotated.
Yes, sir.
Understood? So this whole connection is fixed. Okay. Now what I will do, I will now keep a brush here. Brush means it is just a piece of carbon. It is just a piece of carbon. So now what we are going to do is, you understand DC motor? Now everything arrangement is same. Right? Only thing is, I will remove this part. Now I will use a different mechanism of connection. I will use a different mechanism of connection. Now what is the different mechanism that I am going to use here? Right? So here you see, I will use a concept called ring. This is the ring. Okay? Now most important, you see, this conductor, I will bring it inside and solder it inside. Here, like this.
Yes, sir.
Okay? Then I will use one more ring. And this conductor, I am passing it inside this and bringing it here. Understood?
Yes, sir. Yes, sir.
I am soldering it here. Okay, now there is no connection here. There is no connection here. Got it?
Yes, sir.
It is, the wire is passing like this.
Yes, sir.
You understood that?
Yes,
Now be careful. AC generator. Generator, what you will do? You will rotate the coil. Such that you will rotate the coil for generator. Okay? You will rotate the coil for generator. Okay? And you would be connecting the load. You would be connecting the load. So now, in this position, you will rotate the coil such that this will go up. This side will go up. Okay? Okay, this side will go up. Again, that's a problem. So the magnetic field is into the pole and it is going to go up. So the current is in this direction. So that means the current direction has now got to be ulta. The current direction has now got to be ulta. Get it? Huh? So the direction of the current will be ulta. So the current will go here, and the current will. Now the current is generated by the coil. Okay? In the second half, what happens? This whole mechanism will become ulta, and the current will happen. So as far as the load is concerned, okay, the current will once flow like this, and once flow like this, both the cases, and therefore it is generating alternating current. Understood? Clear to all of you? ಈಗ ನೋಡ್ರಿ ನಾನು ಎಷ್ಟು ಡಯಾಗ್ರಾಮ್ಸ್ ತೆಗೆದೆ ನಿಮ್ಮ ಅನುಕೂಲಕ್ಕೆ ಇಷ್ಟೊಂದು ಡಯಾಗ್ರಾಮ್ ತೆಗೆದಿರಿ. ಈಗ ನೀವು ಎಷ್ಟು ಬೇಕಾದ ಡಯಾಗ್ರಾಮ್ ತೆಗೆದ ಈಗ ಕೂತ್ಕೋರಿ 15 ನಿಮಿಷ ಅದನ್ನ ಮಾಡೇ ಹೋಗ್ರಿ. Understood? You sit here, you complete the homework and go. Sit, work for the sake of Sakshi. So this is the coil. So I have connected. These are the two slip rings, right? Now this slip ring I have connected to this, but actually because of mechanical I am shooting it here. Actually the wire will come here and it will get soldered. Then the other end connector I will pass it through this. Can you see?
Yes, sir.
Board. Then to this also I will connect. So there are two slip rings connected, and now the coil will rotate. If the coil rotates, the slip ring also will rotate. Did you see that?
Yes, sir.
Online students, did you see that?
Yes, sir.
So that is the arrangement. Now, friends, I have conducted some 15 classes. Alright. So the 15 classes I have abstracted the 10 minutes clippings from each of those 15 classes and have made it into 1 hour video. This is like a summary sheet for all. Okay? Now I have already sent to all of you the all the classroom videos. So you can, if you want to know more about it in detail, so you can open those videos also and you can learn. So now you see, with the help of technology, we are able to engineer this form of learning. It is experiential learning, and you must take the full benefit out of it. And if you have any questions, you can write to me. Okay, I will be more than happy to answer. Right? Okay. Thank you so much.